We're going to talk about Chapter 4, Section 3, Problem number 5. Some of you find me slightly non-intuitive. I've switched the order a little bit. This is Part B. This is Part A. So before we discuss the problem, I want you to think about one thing. Well, what we did in class is I said, here's my, Maclaurin series of the function. Could you please tell me from that what is e to the power of, let's say, 2, right? So once I get to that, I realize, oh, that means being summation. That means replacing your x by 2, right? So everything else in your formulation should be changed by 2. So I have summation k goes from 0 to infinity, 2 to the k over 2 factorial, k factorial. So I can find infinite series approximation of e squared pretty easily. So this problem I have here is basically going backwards. Instead of saying, here's my power series, please evaluate it at some particular points. I'm saying, here's my power series. What exactly was it approximating? So I'm going backwards. You do not know the general formulation and then substitute. What you have is after substitution, how does the infinite series look like? Where does it come from in the first place? So let's try to work this one out. Let's think about it a little bit. So which one does it look like? Well, if I were to look at my problem here, right, it's basically summation of 1 over 5 to the power of n. N goes from 0 to infinity. So which one does it look like? Well, this one only has no extra coefficient in the front. It's 1 over 5 to the power of n, so it looks quite similar to this one. Because of the similarity, I realized the only difference I have for this problem, which by the way was k goes from 0 to infinity, 1 over 5 to the k, it's actually changing the x to be 1 over 5. And therefore, let's change the x simultaneously on the other side. So what I'm going to end up with is simply 1 over, right? 1 over 1 minus x being 1 over 5. So you can simplify your calculation and get that final answer. So along the same line of thinking, we can look at my problem one more time and try to do the comparison. So among all the structures I have here, right, which one looks like this? Well, this is summation of -1 to the n, 2 to the 2n, and then 2n factorial, where n goes from 0 to infinity because the lowest order term clearly is n being 0. So if you look at every single one of them, this one actually looks quite similar to that one. They are exactly the same, except where you had x, you have 2 here. Therefore, your x should be replaced by the same expression, so I have cosine of 2 here. This is actually one of the simpler questions because all you need to do is to directly do a quick comparison and they just look identical to each other. The problem could have been slightly more challenging if I tried to modify it a little bit more. For example, what I could have said is my problem is 2 times 2 times 2 times 2 times 2 times. So your final answer is 2 times that. Right, you factor out the 2, so you can end up with 2 cosine 2. So basically what I'm trying to say is the simplest one is your series look exactly like something that identical to our Maclaurin series that's made available. Then just find out how the x was replaced. Then you go back to your original function, replace the x by the same number correspondingly. The problem could have been slightly more challenging if I were to modify my power series just a little bit. So it doesn't look so straightforward, so similar to your original Maclaurin series. So you need to do a little bit of reformulation to get the answer, but hopefully at least to give you an idea how problems like this should generally work out.